Hello everyone, welcome back to my channel Learn with Deepika. Hope you all are having a great day. And in this video, we will be learning about trigonometric identities and their derivation. So let's start from the very basic. What is identity? An equation that is true no matter what values are chosen for variable or identities. You can see these two examples. Now, what are trigonometric identities? Trigonometric identities are equations involving the trigonometric function. For example, sine theta, cos theta, cosecant theta, tan theta, etc. These all are trigonometric functions which hold true for every values of variable involved. You can see the two examples here. Sine theta is equals to 1 upon cosec theta, and another one is sine square theta plus cos square theta is equals to 1. So these two are trigonometric identities. So in this part, we will derive trigonometric identities using Pythagoras theorem. As we know, Pythagoras theorem is opposite side square plus adjacent side square is equals to hypotenuse square. By dividing this complete equation by hypotenuse square, you will get O square upon H square plus adjacent side square upon H square is equals to H square upon H square. You can write this way as well, O upon H whole square plus A upon H whole square is equals to 1. And student, we know O upon H is equals to sine theta. So here we can write sine square theta, and A upon H is equals to cos theta. Cos square theta is equals to 1. So that's our trigonometric identity. And this can be written in different form as well. Like you can write sine square theta is equals to 1 minus cos square theta by shifting cos square theta to right hand side. And also you can write cos square theta is equals to 1 minus sine square theta. Now we will again write this Pythagoras theorem, and in this part we will divide this Pythagoras theorem by adjacent side square. So this will be O square upon A square plus A square upon A square is equals to H square upon A square. This can be written as O upon A whole square plus 1 is equals to H upon A whole square. As we know, O upon A is equals to tan theta. So I'll write tan square theta plus 1 is equals to H upon A is equals to sec theta. So this is secant square theta. And this can be written as tan square theta is equals to sec square theta minus 1. And another way to write is 1 is equals to sec square theta, and by shifting this term to right hand side you will get sec square theta minus tan square theta. So 3 more trigonometric identities, and again we are going to write Pythagoras theorem. Previously we have divided this equation by H square, after that we divided this equation by A square, and now you will divide this equation by O square. So you have to write O square upon O square. A square upon O square is equals to H square upon O square. This can be written as 1 is equals to, it's 1 plus A upon O whole square is equals to H upon O whole square. And we know the formula of A upon O is equals to cot theta. So you can write 1 plus cot square theta is equals to h upon O is equals to cosec theta. So it's cosec square theta. And this can be written as 1 is equals to cosec square theta minus cot square theta. And another one is cot square theta is equals to cosec square theta minus 1. So you can see here we have 9 trigonometric identities, and these are the most commonly used trigonometric identities which we are going to use in exercise 8.4 of Ncert. To memorize these trigonometric identities, you can write it down. This way you will get a feel how it is supposed to be written in exam.